Good evening, everyone, teachers, friends, and guests. My name is Khaled Suleiman, and I will be presenting a defense systems modeling. And the presentation will be following this order. First, computer vision is the power of analyzing visual data. And at this point, we transfer our visual understanding to computers. When this happens, we will move to higher level AI robots. However, I believe this is way far from getting to the point which robots will take over our control. Until that time, we have the freedom of how to use the technology we have in the way we want, and I choose to use it in protective way. So my project aims to implement a simple, real-time or close to real-time defense system, and to protect people as well as facilities. The second objective is to show how we can use simple components, simple electronic components, such as Raspberry Pi with very low specifications, low cost, small camera, and small mechanical gears to implement something really useful. These are the components I'm going to use in my project. The main controller, the main brain will be Raspberry Pi 2. I have done some tests on it and I'm really not satisfied with the performance, so I'm thinking in project 2 I might move to the Tinker board, which is which gives much higher performance. The other two components are the camera, Pi camera, which will be used as input sensor to the system, and the other one is Arduino Uno, which will control the machine gun. This is overview of the project, and this is how it will work. The camera will be monitoring some specific area, and when an object enters this area, it will be processed by the Pi. And then the Pi will detect this motion and send the coordinates of that motion to the laser machine gun, which is controlled by the Arduino. The Arduino will drive the motors to that coordinate and shoot the target by laser. I have done some tests. I installed the software for Pi and did some configuration. So far, I'm getting a picture when any motion happens on the range of the camera, and I'm getting also the coordinate of that motion. And this is also first draft for the machine gun, which will be used to shoot the target or the motion, the point of the motion. For future work, I'll be implementing this design, first verify it, improve it, and then implement it from acrylic glass, which is strong light. And then I will send the coordinates which I got from the Pi right now to the Arduino, and then that one will drive motors and control small laser gun to shoot that target. Thank you.
What the Tinkerboard?
Tinkerboard, it's just advanced version of Raspberry Pi. Almost double frequency, processing, and it has double the RAM. It's 2 gigabytes of RAM. So I assume to get better performance with this board. It's double the price as well.
Okay, well, similar question I already asked the other group. You already have Pi, or you have to have Arduino?
So in order, I did this test and they are not quite fast. So in order to keep the performance high or to increase it more, I will distribute the operations. The Raspberry Pi will take over the heavy operations, processing the streaming video from the camera, and the Arduino will control the motors, will just get the coordinates and drive the motors to the target.
Okay, kind of like explain what happens now. So you see that circle thing up top?
Yeah.
With the camera, you detect it,
Yes.
and then what?
And then when this object enters this area, the camera will see it first. And then
What area?
any area you are interested in. It might be the front door of your house. But
I don't understand. Tell me, I'm very confused. So I have a camera pointing, let's say pointing at a door.
okay.
Then what?
Then when some movement happened in the range of that
And
camera.
if people walk in, you're gonna shoot the people?
No.
So how do you distinct an enemy from a friend?
Yeah. An application of this project will not be for a small protection. For example, airports and drones. Now drones.
No, that's a grand idea, but your project. So what do you plan to detect?
I will throw some random object in front of the camera.
So detect anything in front
Yes,
of the camera.
any motion.
Okay, you have to explain that. I don't
Yes.
understand. You don't say a bomb. You say detect any object.
Any
right?
motion, exactly, yes.
Any motion.
Yes.
Okay. Then what happens when you detect? What happens?
When the Pi detects that motion, it will. The detection algorithm goes as follows. It will take the first frame from the camera and compare it with the right after it frame. Check where's the change in the pixels, and return the coordinate of that pixel, which is X and Y. Once I get X and Y, it will pass it to the Arduino.
So where are you at right now? So pass it to the Arduino. And then
Yes, I'm exactly at this
No,
point.
no. Pass to the Arduino. And
Yeah.
and then what?
Then the Arduino will control the machine, which I'm implementing now. It will drive the motors to that point and shoot it by laser.
Okay. Now here's the problem. If the object moves up,
Mhm.
what's going to happen?
It's motion. It will be shot.
But you have to calculate the speed. So you take only one picture. How do you know the speed of the moving object? It would shoot at the past position, not the future position.
This is why the system, I'm not quite sure I will use Pi, because it's slow. It will not shoot at the same time. Plus, the shooting time, it's almost super small because it's laser. Once it gives an order.
Yeah, I understand. I understand what you're doing, but I'm talking about reality here.
Yeah.
You have an object that can move north, east, west, whatever it is, right? You have to determine the direction first, right? Because it's moving. So you're going to shoot the object, right? So how do you know which way it's going to move?
Initially, nothing should be moved in the picture, in the range. Once you turn on the device, so nothing is gonna move. So for sure, the first time something will move, it will move from one side of the range of the camera.
So what's your project? What's project 2 that I'm gonna see?
Yeah, the thing you're gonna see is this part.
What is that part?
This part is the draft of it. This one. It's just initial draft, and I'm going to cut it.
No, tell me the entire project. What am I expect to see in project 2?
You will see machine moving and shooting stuff.
Okay. There are a few problems. Number one, I don't think you're gonna finish it in time. You're only one person project, right?
I'm ahead from.
How?
I'm allowed ahead from many people, so I'll be fine, I think.
So what happens if you don't finish? Because I'm gonna be telling you all the problems that I see, right? You're gonna say the machine's gonna shoot, so the object's gonna be there or not be there, not moving. That's what you plan, right?
It will be moving. When it moves, it generates the motion.
Right. And then how do you know which way it's gonna move?
It doesn't matter as long as I'm getting its coordinate every second almost.
Right, but if we shoot at the past coordinate, not the future coordinates.
This is the point. It's a real time. So once I get the coordinate, the
Right.
object won't have time to move to.
What do you mean? It's moving. It's
Yes.
not standing still.
Once.
Hey, like this, I see you, right? You're running across the stage. I will shoot at the point that you start running, but you're already there. I can't shoot you.
It's super high processing. So once the moment you enter the range, you
I
will be.
know high processing, but it's not a time machine. You're shooting at the past, not the future.
Okay, in this case, I can make some scaling on the Arduino to shoot 1 second ahead.
Back to the same question.
Mm.
I don't think you're gonna finish it in time. You have to think about the objective, the requirements. It's going down. It's too big.
Not yet, no.
That's what you should have first. Before you start with working on anything with your real hands, right? You design it first. You improve the command, right? In order to not have to waste money cutting the bits of glass, buying the servo motors. So if you find exactly what the limitations and the requirements are, you don't have to buy the super fast servos that cost maybe $100,000. You can make do with maybe something cheaper like second motor, right? So you first have to set what target are you going to fire? How big is the target? Will that target represent how many degrees or fraction of degree? Those sort of things. You should answer that first. If you answer that, it makes your life easier. You can answer what is the question? What's easier? Of course, you have a huge object that moves very slowly. A very slow microprocessor can handle that. But if I'm going to throw a piece of chalk over there, and your laser is going to light up all the way, that's going to be very expensive. Exponentially expensive, right? So you have to find a very, very, I would say, daring project, but you need to kind of like set your exactly what you want. Okay, and then try to allocate time to it.
Okay, anyhow, let us see your projecting or project 2 or not.
The idea is
Because we are
you
worried
have to
about
think about the movement because when you actually make it, you will face the problem, I think. Because even though the analyzing part and the communication part can make it the second, but the model part, you cannot make it that fast. You still face some delay for sure. Also, the other thing is the sizing. This is why we not like to be one person. The sizing is quite big.
There's one part as well as one third part, right? Show your third part. But when you start controlling things that are just outside of your grids, it might not be to your expectation. We're just afraid of that. But if you do enough planning, do enough research, do enough proving and object unique. So we hope the best with this.
Okay, thank you.